question from the Gauteng Prelim 2023. Question 9. Sketched below is the graph of f prime, the derivative of f. Points A, B, and C are the intercepts of f prime with the axis. 9.1.1. Write down the coordinate of A. Okay, so A is the y-intercept of the derivative of f. So we need to find the derivative of f in order to find the coordinates of A. F of x is equals to minus 2x cubed minus 3x squared plus 12x plus 20. The derivative of f is given by minus 6x squared minus 6x plus 12. And then we're just going to say for y-intercept, set x equals to 0, then we're going to have a 0 and a 0. So the coordinates of A will be 0 is to 12. 9.1.2. Determine the coordinates of B and C. B and C are the x-intercept for the derivative of f. The derivative of f is equals to minus 6x squared minus 6x plus 12. For x-intercept, we let y be equals to 0. We'll be left with 6x squared plus 6x minus 12 is equals to 0. And then I'm just going to divide everything by 6. Then I'm going to be left with x squared plus x minus 2. This is an x and x, 2 and a 1. That is going to be positive. That's going to be a minus. X should be equals to 1 or x should be equals to negative 2. They want their coordinates. So the coordinates of B is negative 2 is to 0. And the coordinates of C is 1 is to 0. 9.1.3. Which points on the graph of f will have the same x value as B and C? Okay. Well, the sketch of f, the value of A there is less than 0. So I am going to have a increasing function. So my drawing will look like that because the value of A is a 0. The x-intercept of the derivative, so the x-intercept of the parabola, they give you the x values of the turning points of f. My graph will look something like that. And then the value of the x value of the turning point will be x is equals to a 1, and then there I will have a 2. So this is a repeated root. So it's minus 2 is to 0, and that is going to be a 1 is to y. Okay. So the turning points will have the exact same x value as B and C. 9.1.4. For which values of x will f be increasing? So they want where the gradient of f is positive. So from that point to the turning point, we can see that the gradient is positive. So x should lie between a 1 and a negative 2. 9.1.5. Determine the y-coordinate of the point of inflection. The point of inflection will be somewhere there. In order to find the x value for the point of inflection, we just say x1 plus x2 over 2. We use the x values of the coordinates of the turning point. This is a minus 2, that is a 1 over 2. This is going to be negative 1 over 2. Or you can just say f of x is equals to minus 2x cubed minus 3x squared plus 12x plus 20. And then the first derivative, we know it is going to be a minus 6x squared minus 6x plus 12. In order to find the point of inflection, you need to find the second derivative. So this is a minus 12x minus 6. And then you equate that to 0. So this is 12x should be equals to a 6. Therefore, x should be equals to negative 1 over 2. But they are looking for the y value, not for the x value. So I'm going to substitute that into f, negative 1 over 2 cubed minus 3 into negative 1 over 2 squared plus 12 minus 1 over 2 plus 20. Minus 2 into minus 1 over 2 cubed minus 3 minus 1 over 2 squared plus 12 minus 1 over 2 plus 20. This gives me 27 over 2. Okay. 9.2. The tangent at P to the curve is given by intersects the x-axis at point R. Line PT is drawn perpendicular to the x-axis with T on the x-axis. Determine the length of RT. So this is a different question. It has nothing to do with 9.1. Okay. Y is equals to negative x squared minus 1. Okay, the value of A is less than 0. The original graph of a parabola looks something like that. It looks something like that. This is when you have y is equals to negative x squared. So now I have a minus 1. So I'm shifting the graph 1 unit down. So my graph will look something like that. And then the coordinate of the turning point will be 0 is 2 minus 1. Okay. They tell me that the tangent at P, so that is P is 3 is to minus 10. Okay. Intersects the x-axis at point R. Okay, so I'll have a tangent that goes like that. I'm not sure where it intersects, but I know that it intersects the x-axis at R. Okay. Line PT is perpendicular to the x-axis with T on the x-axis. So I have a T there. And then I have this line perpendicular to the x-axis. Okay. Determine the length of RT. Okay. Y is equals to negative x squared minus 1. We know that the equation of a tangent is given by y is equals to mx plus c. We need to find what the gradient is. In order to find the gradient, we need to find the derivative of the parabola. This is minus 2x. I want to know what the gradient is at the point P when x is equals to 3. So I'm going to substitute the 3 there. So the gradient is minus 6. Y is equals to minus 6x plus c. And I'm going to substitute the point P. This is minus 10 is equals to minus 6 into 3 plus c. So c is equals to minus 10 plus 6 times 3, which is an 8. Okay, that's fine. They told me that intersects the x-axis at point R. So R lies on the x-axis. Now I know what my equation of a tangent is, 6x plus 8. And then R lies on the x-axis. In order to find the coordinates of the x-intercept, I let y is equals to 0. Minus 6x plus an 8. Therefore, my x should be equals to 8 divided by 6, which is a 4 over 3. So the coordinates of r is 4 over 3 is 2, a 0. And then they told me that this is parallel to that. So the x value won't change. I'll still have a 3 there. The length of RT should be equals to 3 minus 4 over 3. I am getting 5 over 3, which is 1.67 units.